Hello students, let us see few questions from class 10 mathematics topic polynomials. Question number 1. So this is a 1 mark type of question. They have asked us the value of k for which minus 4 is a 0 of the given polynomial. So as you know, for finding the zeros, we equate the polynomial to 0. So in this question, they have already given that minus 4 is a 0. So by substituting minus 4 into the polynomial in place of x, we will equate it to 0. And when we will solve it, the value of k, we got it as 9. Now moving on to the next question. Again a 1 mark type of question. The number of polynomials having zeros minus 2 and 5 is dash. So as you know, the direct answer to this particular question is infinitely many polynomials are possible whose zeros are minus 2 and 5. So let us see the logic behind this. As the general form of the polynomial with alpha and beta as the zeros is given by k times x square minus alpha plus beta times x plus alpha beta, where k is any real number. Therefore, adding the zeros and finding the product of the zeros, we get one of the polynomial as x square minus 3x minus 10. But since we have the general form as k times the polynomial, so where k is any real number, if we multiply this polynomial by any real number, we will get infinitely many polynomials whose zeros are same. That is the reason we get an answer as infinitely many polynomials whose zeros are minus 2 and 5. Moving on to the next question, number 3. A 2 mark type of question. Now here they have asked us find a quadratic polynomial whose zeros are minus 2 and minus 5. So we will find the sum of the zeros. Alpha plus beta we got minus 7. Product of zeros we got it as 10. And as you know, the general form of the polynomial is k times x square minus alpha plus beta times x plus alpha beta, where k is any real number. So substituting the alpha plus beta and alpha into beta values, we got k times x square plus 7x plus 10. So again children, mentioning k times is very important. So as they have asked us find a quadratic polynomial, so here we can say k times x square plus 7x plus 10, where k is equal to 1. Okay, so if you don't write this k, okay, so there may be chances of losing half a mark. So please be careful. Moving on to the next question, a 3 mark type of question. Find the zeros of the polynomial and verify the relationship between coefficients and zeros of the polynomial. So this question is a very important question regarding board point of view. Okay, so as we know, when we want to find the zeros of the polynomial, we equate it to 0. So therefore equating the polynomial to 0 and then multiplying both sides by 6. So we get our polynomial as 6x square plus x minus 12 equal to 0. Then using splitting middle term method and factorizing, we got our zeros as x is equal to 4 by 3 and minus 3 by 2. Now one part of the question is solved. Let us move on to the another part, verification part. So here on LHS side, we will write sum of zeros. 4 plus 3 plus minus 3 by 2, we got minus by 1 by 6. And product of zeros, we got minus 2. Now on the RHS side, we have to write it in the coefficient form. So alpha plus beta is equal to minus b by a, which is minus coefficient of x upon coefficient of x square, which is coming as minus 1 by 6. And alpha beta is equal to c by a, which is constant term upon coefficient of x square, which is coming as minus 2. So as we have seen, LHS equal to RHS in both the cases, sum of zeros and product of zeros. Therefore, our verification is done. Now moving on to the next question, question number 5. It is a 5-mark type of question. Alpha and beta are the zeros of the given polynomial, and also they have given alpha square plus beta square is equal to 24. We have to find k and also find alpha inverse plus beta inverse. So, by using our identity, rearranging our identity of alpha plus beta whole square, we will get alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. and which is given as 24. So as we know from the given polynomial, we will put the value of alpha plus beta as minus b by a is minus 4 by k, and alpha into beta is coming c by a, which is 4 by k. So substituting these values in the above identity, so and then rearranging the equation, then dividing both sides by 8, we get our final equation as 3k square plus k minus 2 is equal to 0. So by using splitting middle term method, we got k is equal to minus 1 or k is equal to 2 by 3. So now k value we have solved. So one part of the question is done. Now alpha inverse plus beta inverse is nothing but 1 by alpha plus 1 by beta. LCM we will take alpha beta, and then in numerator we got beta plus alpha. So we already know our alpha plus beta and alpha into beta value. We have seen above, and then we will substitute it. Minus 4 by k divided by 4 by k, it comes minus 1. So this is the way we have to do these sums. Hope this was helpful for you, dear children. Thank you.